Alrighty, good morning, Hamilton County 4th graders. We are having technical difficulties today. My video just got deleted. But it's okay. It's okay. It deleted halfway through my recording. So today is, we're going to try this again. Today is week 5, day 5. We are continuing with our adding and subtracting angles from yesterday, working in the instructional book, page 318 through 319, page 323 through 324 in the practice, and then we have day 16 countdown. Now, I'm just going to walk you through what I've done so far. The marks are already there because I was already in the middle of recording this when my camera decided to stop recording it. Anyhow, so we're talking about combining angles, and just from what we know about the word combining, we know that we're going to be adding and not subtracting. The problem states, Waylon and Andreas play a game where the goal is to fill a tray with 3 same-size triangular game pieces. Alright, so these are our 3 triangular game pieces, and they are all the same size. There are no gaps and no overlaps, so they're lying exactly side by side. And they want to know what is the measure of the bottom angle of the tray. So, remember, these are individuals right here that each have, let's look at it down here, that each have the 50-degree angle. This one belongs to that one belongs to this one, and this 50-degree angle belongs to him. But we're not talking about separating angles. We're combining them. And when we said when we combine, we're using addition. So, when we use addition, we can do 50 plus 50 plus 50, and that would equal 150 degrees. This model down here is showing you how you could use that as with a protractor. So remember, protractors are a lot like number lines, but instead of being a flat line or straight line, it's a circle or half of a circle. So we can go 50 degrees, that'd be that first angle. Jump again, 50 degrees, there's that second angle. Jump again, and there's that third angle. And you can see right there, just as like when we were using the number line to add whole numbers, we just got our answer. And if we break it down, let's just review it one more time on the back, filling out the back part. So number 2, how many 50-degree angles compose the bottom angle of the tray? Well, we counted 3 game pieces. Does addition or subtraction best express putting 2 or more angles together to make a greater angle? Well, obviously it's not going to be subtraction. Even in here, it says putting them together, or there it goes. Alright, number 4. You can write an equation to combine the 50-degree angles to compose the bottom angle of the tray. Now, don't ignore this part. We already said it was 50 plus 50 plus 50 equaled 150. The reason I have this up here is because of number 5. Number 5 said, could I compose an angle that measures 150 degrees from 3 angles with unequal angle measures? So we started off with all of our angles were 50 degrees, and we just added them up. They're asking, well, what if they're unequal? Could it still equal 150 degrees? Well, of course we could. All, numbers have more than one sum. There's probably like 3-4 ways to make 8. There's probably, a bunch of ways to make 100. So all we'd have to do, 30 degrees plus 70 degrees plus 50 degrees, that would be 150 degrees. You could even say 60 degrees plus 60 degrees plus 40 degrees. That would be 150. See what I'm saying? Alright. So number 6. The angle between each spoke on a wheel. So I had to Google this on the last video. I wasn't sure what a spoke was, but this is a spoke. Maybe I should do that in a different color because I have a bunch of orange marks on that wheel from earlier. Alright, so this would be 115-degree angle. Sophia puts reflectors on 2 spokes as shown on the right. So we have reflector here, reflector here. What is the measure of the angle between the spokes? So we were trying to find the measure between the spokes with the reflectors. Now, if each of these angles is 15 degrees, we increase by 15 1 degree turns each time we have a new spoke. So if we do 15, and how many spokes do we have? That was 1, 2, 3, 4, 5, 6, and 7. And we just do 15 times 7. I don't know why I put that up there. 7 times 5 is, oh, you know what? We're supposed to be adding angles. So, we can do 15 plus 15 plus 15, 7 times. 15 plus 15 plus 15 plus 15. That's 1, 2, 3, 4, 5, 6, and 7. Whew, that was a lot. You know, I don't know why I'm doing this. Multiplication is the same thing as repeated addition, but we'll just work through it. So we have 5, 10, 15, 20, 25, 30, 35. Carry the 3, 3, 4, 5, 6, 7, 8, 9, 10. So 105, or if we had multiplied, we would have gotten the same exact answer. Just saying. Anyway, number 7. Gina sets 2 floor tiles as shown. What is the measure of the blue angle? You're kidding me, right? How am I supposed to? Okay. Hang on. Let me label this blue circle. Alright. So the blue circle is this one. And then the red circle is this one. Okay. Now that I colored it for myself, Jana set 2 floor tiles as shown. What is the measure of the blue angle? So the blue angle would be the sum of the 2 red angles. So the 2 red angles, if you look, okay, so this is talking about this angle right here. This is 108. But then we had another angle that was made in that circle that was 53. So the angle of the blue angle, or the measure of the blue angle, is going to be the sum of 108 and 53, which would be 161 degrees. Okay. Moving on to the practice page. Page 323. Our example. A spotlight in a theater casts a beam that has an angle measure of 24 degrees. 24 degrees. If 4 spotlights are placed so that they have a common endpoint, what is the measure of the greater angle formed by the beams of all 4 spotlights? So they started off with 1, but then they said if 4 were placed and they would have the same endpoint right here, what would be the measure of that angle? And we would take each measurement and combine. So 24 plus 24 plus 24 plus 24, which is the same thing, which is repeated addition, right? So we could just say 24 times 4 and get the same answer. Number 1, look at the example above. Suppose 3 spotlights are placed to have a common endpoint. What is the measure of the angle formed by the beam of the 3 spotlights? Write an addition equation to find the measure of the angle. So instead of having 4, we are only going to have these three right here. Sorry, that should have been times 5. We would do, I keep going back to the orange, man. Leave the orange alone. We would do 24 plus 24 plus 24. Ooh, and I missed this side. He's a part of these guys too. Alright, so 24 plus 24 plus 24, which would be 4, 8, 12. Carry the 2, 2, 4, 6, 7. 72 degrees. Another way to compose a 96-degree angle is to combine two angles, a 90-degree angle and a 6-degree angle. Write an addition equation to show why this is true. Well, if we combine a 90-degree angle and we combine it using our plus sign with a 6-degree angle, we get 96 degrees. Oh my gosh. When we get a 90-degree angle and we combine it with our addition sign and add it in with a 6-degree angle, we get 96 degrees. Alright, number 3. Tell whether, easy does it. Tell whether each statement is true or false. I'm just going to pause this for a second and make sure this was nothing like super duper important that I keep hearing. Alright, sorry about that. Alright, number 3. Tell whether each statement is true or false. A 20-degree angle and a 70-degree angle can be composed into a 90-degree angle. So when we say composed is like combined. And when we combine, we use addition. So if we have a 20-degree angle and we combine using our addition sign to a 70-degree angle, we would have 7, 8, and 90 degrees. So this would be true. Number B. 3 50-degree angles compose an angle that measures 350 degrees. Remember, compose is the same as addition. So we would do 50 degrees plus 50 degrees plus 50 degrees. And we would get, that's 5, 10, 15, 150 degrees, which is not 130. So that is false. A 15-degree angle and a 60-degree angle compose an angle that measures 75 degrees. Remember, same as combining, same as addition. We do 15 degrees plus 60 degrees, and we get, 75 degrees. D. 4 50-degree angles can be composed into a 200-degree angle. So composed would be combining, adding, and you want to make sure you see that that's 4. So it would be 50 degrees plus 50 degrees plus 50 degrees plus 50 degrees, which would be 5, 10, 15, 20 with a 0. That is 100% true. Alright, number 4. Look at the drawing of a hand fan at the right. The angle between each wooden stick on the fan is 12 degrees. So right here is 12 degrees. If 11 of these angles combine to form the open fan, what is the measure of the purple angle of the fan? So the purple angle, this whole angle right here, what all of these smaller 12-degree angles make up with, or are composed of, and it's saying that there are 11 of them. So we could either use repeated addition, or you can multiply 11 times 12, which 2 times 1 is 2. We'll just do the standard algorithm. 2 times 1 is 2. We have our placeholder. 1 times 1 is 1. 1 times 1 is 1. And we end up with 132. You could have also, I'll show you the area model just because we haven't really played with it in about a week, I don't think. But if we were going to use the area model, we've got 11 as expanded would be 10 plus 1. 12 would be 10 plus 2. And we have 10 times 10, 10 times 2, 10 times 1, and 10 times 2. Or excuse me, 1 times 2. There we go. And then we have, that's 100, 20, 10, and 2, which would be 132. Get the same answer. Alrighty, number 5. Sam lifts the front of his skateboard at a 15-degree angle to the ground as he gets ready to jump. Like so, he starts here. He lifts the front of his skateboard at a 50-degree angle from the ground as he gets ready to jump. He lifts his skateboard another 27 degrees when he jumps. What is the measure of the angle that Sam lifts his skateboard from the ground? So we have a much larger angle here that's composed of 27 degrees and 15 degrees. And when we say compose, we combine. And that would be 6, 7, 8, 9, 10, 11, 12. Carry the 1. 42. 42 degrees. Alright. Almost ready for the weekend. We have our countdown, and that is it. I'm telling you guys, I have been so ready for this weekend, and it looks like it's supposed to be really pretty. Like, it's really pretty outside right now, and I can't wait to get done with work so I can go outside and just enjoy the day. Ugh, and it's supposed to be like this all weekend. Alright, day 16. An expression is shown. 800 divided by 80. What is the value of the expression? So we need to divide this out. If we just did 8 divided by 8, what times 8 would be 8? Or excuse me, yeah, what times 8 would be 8? 1. 1 times 8 would be 8. And then all you need to do is look at how many zeros you would have left over. So these 2 zeros can cancel out, and you only have 1 left over, and you get 10 as your answer. Excuse me, I'm just checking my email. That it's just been buzzing today. For it being a Friday, I don't know. Alright, number 2. How many times larger is the value 250,000 than 250? This is going back to place value. Remember how when we go up in the place value chart, we times by 10. So if you think this is, how many times larger is the value 250,000? So this only has, let's say, we're at 1 place value. This has 1, 2, 3, 4, 5, or 4. It would be 4. So it would be 1,000. And we can check by saying, all right, if I multiply 1,000 by 250, well, 250 times 1 is 250. And then we have 3 zeros. Just like that. How many times greater is the value of 3 in 300 than the value of 3 in 30? Well, we started off in our tens place, and we went up 1 place value to the hundreds place for the 300. So every time we move up a place value, we times by 10. 10 times. You can just put that there. Alright, number 4. Which phrase represents 253? So we're looking for word form. And I always say when you're trying to find word form, read it out loud. If we start down here, we want 253. This is 2053. That's not right. This is 25 and 3. That's not right. 253. There we go. Just like that. If you say it out loud, it'll make sense to your brain. Alright, now we have write this jumbled mess as a number. And when we're doing this, remember, they don't show you parentheses here, but it's much easier if you look at it as parentheses because it keeps your operations separate. So 6 times 1 would be 6, and we would have 4 zeros. And then we would add 5 times 1 is 5 with 3 zeros. 2 times 1 is 2 with 2 zeros. And 3 times 1 is 3. And then we just add them all together. I have 3 in my ones. I have nothing in my tens. I have 2 in my hundreds. I have a 5 in my thousands. And I have a 6 in my 10,000s. We're done. We are done for the week. Oh, I'm so happy. I am so happy. I did want to talk to you guys real quick about the Zoom meeting for Monday. We are having a Zoom meeting. If you cannot access the Facebook page where we put the links, message me and I will send you a personal link so you can join class. We're all trying to create guitars to show. So, like I know Dulce said she was going to create a guitar. I'm going to try and create a guitar. I'm not the craftiest of person, but we'll see how it goes. So, if you're bored this weekend and you got some, random stuff laying around that you might think could make a pretty cool guitar, go for it. We're going to share ours on Monday at the Zoom. Alright, guys. Also, you guys are doing awesome on your DBAs. You may not feel like it too much. I might have to, guide you a little bit. But for the environment we're in now, I mean, you guys are impressing me. You really are. I am so floored and I'm so impressed and I'm so proud of you guys for working as hard as you guys are. These circumstances aren't easy, and you guys are tackling it like a bunch of champs. And all of us are just very impressed with you guys. So great job. Keep up the good work. Have an awesome weekend. Get outside, play in this awesome weather. We actually are not supposed to get storms this weekend. Make your guitars or make something to show to everybody on Monday. And, yeah. I love you guys. I miss you guys. Bye.